So we learned what these numbers mean. We are focusing on this table, and we learned explain sum of squares and residual sum of squares. And the third row is the total sum of squares. Total sum of squares is the total variation in the original actual outcome variable. In our example, it is the GDP growth rate. So GDP growth rate within 65 countries has this much variation. So that is the total sum of squares, and its degrees of freedom. Its degrees of freedom is the sample size minus 1. You lose 1 in estimating, in calculating the sample mean. Or you may think the sample mean is the rule is equivalent to the intercept. So anyhow, intercept plays the same role as the mean. So and of course the mean squared error will be calculated as the ratio between these two. So you know everything in this table. We learned what this table means and what these mean and what the number of observations and R squared and root mean squared error mean. So that's what we have learned in the lecture. So now let me explain a little more relationship among those numbers, some hidden relationships. First, remember, total sum of squares can be decomposed into the sum of the explained sum of squares and residual sum of squares. So that is, so the GDP growth rate varies this much. It varies this much. So total variation in the GDP growth rate is 230 something. But after you estimate the regression model, only one variable of with the trade share, you could explain only about 28 of the total variation. 28 is how much you explained, and the other remaining 201 something is not explained. So if you use the calculator and check this, then you should get exact equality. Otherwise, I believe Stata would not have any error, but there may be rounding errors. The rounding may cause some minor difference, but that's still like how many decimal places. That will be still very minor. Anyhow, always you should be able to decompose the total sum of squares into two sum of squares given above. And another relationship is among the sum of squares and R squares. R squared is 12.37%, which is calculated as the ratio of the proportion of the explained sum of squares out of the total variation. So if you calculate the ratio out of 230, you could explain about 28, which is 12.37%. That is the R squared. And as the R squared increases, your regression is doing better. Your regression is predicting the results better and more accurately. Okay, I think this is it. This video is relatively short. I'm going to stop here, and in the next video, I am going to start chapter 5, and I hope it helps you do the homework. And if you have any questions, please stop by my office hour or send me an email. Feel free to shoot me an email whenever you have questions, anything to suggest. Okay, good luck with Stata, and see you in the next video. Bye.